So far in our log experience, we've seen logs that look like this, log with a 2, log with a 10. In fact, we already know that when we have a 10, we don't even need to write it. Simply log right there. That's called the common log. Shows up so often because we probably have 10, no, we definitely have 10 fingers. It's probably called common because we have 10 fingers. So natural log is another interesting natural log. It's another log that shows up a lot, but just not in your experience yet, okay? It shows up in math a lot, and this is what the natural log is called. The natural log is equal to the log to the log with an e. So see that small e? And you say to yourself, what the Gehenna is e? Well, let's identify what it is. We all are very familiar with this number right here, pi. You don't have to write this. Just writing it down, 3.141592654, etc. So that is a number that shows up in circles quite a bit, actually shows up in a lot of other places. We actually know another number that's a letter, I. We already know that one. We know that's exactly equal to the square root of -1. So there are letters that represent numbers. In science, there are letters that represent number. G, and I can't remember if it's small g or little g, but that is 9.81. Why? Because it's meters per second squared. It's how much the Earth's gravity pulls us down. So that's G there, maybe capital G. So there are lots of letters that we use for constants. We use letters for constants. Another more famous one, which we don't deal with much, is called phi. It's called the golden ratio, 1.618. And that has to do with Fibonacci sequence, etc. So there are lots of mathematical constants that we deal with. Well, E shows up quite a bit, and in fact, if you can change this to an approximate, it's 2.71, approximately 2.71. And this shows up especially in things that are growing, in compound interest, for example, when we are growing money in a bank account. This shows up in population growth. So it shows up, this number shows up so much that it got its own letter. Again, it's an infinite decimal here, so that's why we're saying an approximate value, just like pi is approximately 3.14. So E shows up, so that's what this is right here. We write it as this, ln, which means the natural log, kind of backwards, but it's probably based on a French or logarithmique naturel or something like that. And so some calculators actually say this, log with a small e. And some calculators will just have ln. So I believe your TIs have ln. And some iOS calculators I've seen have this. Okay, so let's walk through and see an application of this. So we're going to go back and forth between E, and we're going to go back and forth between the natural log and E. So let's walk through an example of this. You might not understand everything about it. That's completely understandable. But what we want to be able to do is to take something that might seem complex to us and be able to apply it in situations. So you deposited $500 into an account that compounds interest continuously. Compounds interest continuously. What's that mean? Not every second, not every minute, not every day, not every hour, but every moment. Just always keeps compounding. Let me undo. At the rate of 4.5%. So we're going to use this formula where A is the amount you have after T years. So A is going to be the accrued amount. So I start off with $750. So in 1 year, I'm going to have $767 or something. All right, T years at the rate of R. So R is my rate, and P, of course, means principal, my initial amount. So when will you have the following amounts? So let's see how this applies. What I do is I take this formula right there, and I want to put the 750 in for A. My initial amount is called my principal, and that's $500. So all I'm asking is if I put $500 in the bank account, when will I get $750? When will they give me total of $250 for free, just for my money to be in the bank, or whatever this is? All right, so now my rate is this right here, so I'm going to convert that to a decimal. Instead of 4.5%, we're going to write 0.045. And of course, I don't know what my t is because that's the question. When will I have $750? So, E looks funny to you, but it's less complicated than you think. What we're actually going to do is just take the E and use log, convert that out. So the first thing I want to do is get rid of that 500, so I'm going to divide both sides by 500. And then this here will give me 1.5 is equal to E to the 0.045t. Remember that what we just defined earlier is that natural log is log with base E. So if I effectively convert this to natural log, it's going to look like this. The natural log of 1.5 is equal to 0.045t. Now what did I do there? Just to recall, this base is now under there. So I said, I took natural log here of this 1.5 equals the exponent over there, like so. Now, I can plug this into my calculator, the natural log of 1.5. So this here becomes approximately 4055 as a decimal. And this here stays the same. Now notice I'm not even going to clear this out of my calculator. I'm going to keep this value in my calculator. All I have to do is divide by that 4.5%. When we bring this down, it's approximately 9 years. So just to answer the question, using the formula, when will you have the following amounts? So the first one here would be approximately after 9 years. After 9 years. So that's just a very interesting thing. You do absolutely nothing with your money. You can put it in a piggy bank in your house, and after 9 years, you'll still have $500. But if you put it in a bank with this interest, you'll have $750 for nothing, for letting it sit in the bank. So we're going to walk through. What we started with was a complex situation. We're going to back up a little bit, go a little more simple here, just to walk you through how this is. So remember, E is a special number. It's 2.71. You don't have to ever write this down, but you should at some point in time think about it, that when I take 2.71 and raise it to a power, I should get 9. So I'm looking for that exponent. So how do we do that? Well, I'm going to rewrite the E in terms of natural log. So rewrite into log, and I'll just say ln for natural log there. So the natural log of 9 is equal to my x here. The rest of it, this is just calculator. Punch that into your calculator. Natural log of 9. 2.197. And there we go. Not overly complicated. This one here, just like we've seen before, yesterday we're looking at problems or previous like this too. All we have to do is isolate the E first. I'm going to subtract 4 from both sides. So E to the 5 minus 3x is equal to 2. So I isolate the power, or in this case, E being the base. Next, I'm going to natural log, rewrite as a natural log. So the natural log of 2 is equal to this exponent. 5 minus 3x. And now we calculate and isolate. 0.6931 is approximately 5 minus 3x. But I'm going to leave this in my calculator right here and then subtract 5 and divide by negative 3. So x is approximately 1.43. That's not a 3. 356. All that was done on your calculator. from the natural log. Now we're going to look at how to solve logarithmic equations, and we're just going to make the decision based on what the base of the log is. So this one here first has a base of 10. So I know when I say 10 to the 1 power, it's going to equal this binomial 2x plus 1. So I rewrote that into exponential form. Now I can simplify here, and then I can subtract 1 on both sides, and lastly divide by 2. So x is 9/2, or if you prefer, 4.5. Now we're going to look at this natural log equation and do virtually the same thing. But remembering that natural log is just log with a base e. So the first thing I want to do is add 2 to both sides in order to isolate the log, or the natural log in this case. So the natural log of x plus 3 is going to equal 10. All right, now I have to say e to the 10th power is going to give me this binomial, x plus 3. Now this gets to be a rather large number right here, so I can plug this part into the calculator, e to the 10th, and then we have to subtract 3 from both sides. So putting e to the 10th in the calculator gives me 22,000-ish. So when I subtract 3 from both sides, I now have 22,023.5-ish. We can always plug that in to do a double check. All right, so natural log and log are virtually the same. All we have to do is consider what is the base on it. This case is a common log is a 10. And this has a base of e. And again, e simply means 2.72-ish. All right, have a good mathematical day.